All right, you guys got some idea of what blue oil is all about, right? Because part of engine performance is knowing how to diagnose the basic engine stuff. You got an engine that you're trying to fix something kind of, well, like for example, when Zane was looking at that the other day, the guy was complaining, of course, the guy knew he had a skip, but he also said, I'm getting lousy gas mileage, I have to stay too deep into the throttle whenever I'm going. And what else is affected when you have to stay too deep into the throttle to keep your speed? Transmission shifts hard and late, right? Because you're deeper into it, it thinks you got more of a load on it. And so a lot of the times engine performance issues can cause the transmission to not shift right. You got to pay attention to that. Huh?
It was a manual. It was a manual.
That one was a manual. Okay, I didn't drive it. I didn't know what it was. Of course, still his fuel economy and everything else was going south, and he knew that he's had to put more gas mileage was horrible and that kind of thing. Besides, he said he decided to pull that head off when he comes back from wherever he works, and he said he's got a buddy that's going to help him do it. It's an old Chevy mechanic or something. That'll be okay, but that thing's got that funky timing chain on it and all this stuff. I mean, they'll probably do all right. Oil is getting into the combustion chamber, either past the piston rings or past the valve stem seal. Watch your pistons rings, because a lot of the times, if you know the bottom ring on your piston is like a squeegee. It's supposed to squeegee that oil off those cylinder walls, and what will happen is sometimes it'll get sort of clogged up so that it can't do its job, and it'll leave too much oil in there, and it winds up leaving enough on the cylinder walls where it keeps going out. Now remember, Luke's car, the little Toyota out here, McBride found, I kept noticing an oil leak under there. We put dye in there, and we were looking, and somebody had looked at it over there and thought the rack and pinion was leaking, and it turned out that the oil leak that was coming out of that car was all coming out around the oil filler cap, because the seal was hard, which was strange, you know, but it's where dye showed. We cleaned everything up, we cranked it up and drove it around, came back, and it was coming out of the oil filler cap. Even though the cap was tight, the seal was hard, and it wouldn't keep the oil in there. Valve stem seals. Which valve stem seal is going to cause oil consumption? Intake or exhaust? Intake. Why? Look at what's around the bottom of that valve stem, low pressure. You're going to have vacuum typically. So it's going to pull oil past that valve stem seal down into that stream, and that's going to cause you some issues. Blue smoke only after startup is usually defective valve stem seal. We've seen that. Drives around, if it's idling and it starts to smoke white when it's idling, but it doesn't smoke when you're driving down the road, or if somebody cranks it up and it makes a big blue cloud of smoke that wafts out across the parking lot and smokes everybody out. Typically valve stem seal stuff. I like to try to do the valve stem seals whenever possible with the cylinder head still on the car. You know, at the Toyota place, they will actually pull the head off and send it to a machine shop to get the valve stem seals replaced, but you can do it on the car, even on a Camry, even on the ones with the timing chains. And we went over that one time before. All right. Black exhaust smoke is excessive fuel. That's your hydrocarbons. That's your soot. That's the stuff that makes your spark plugs look sooty and black and burnt like you see these over there, because it turns into, well, you notice when we were doing the torch work a while ago, and we would have just the yellow flame, you'd see a bunch of black smoke, you know, wafting off of it, and that's a similar kind of thing you're talking about here. White smoke is normal during cold weather, and that's steam. Why are you seeing steam in cold weather coming out your exhaust? You know you've seen it. You crank it up in a cold weather. Steam. Where does that come from?
You know, from the warm exhaust, and it's steam, and it condenses in the cold air.
Yeah. So you're basically, well, you're making a gallon of water for every gallon of gas you burn. I mean, in the engine, it's creating water in there, and so when that water comes out the pipe. Have you ever noticed when you're looking up under a vehicle, a lot of times the muffler will have a little hole in it? And the hole is there so that the water that's naturally going to be there can drain out. Mm-hmm. You know, that doesn't mean you got a bad muffler. It basically means that sometimes when you do a smoke test on the exhaust system, you'll see smoke spurting out of that little hole, and you'll think you got a problem, but you really don't. Every engine makes about a gallon of water for each gallon of gas. If the steam from the exhaust is excessive and it keeps on coming, and coolest getting into the combustion chamber. One time we did some work on an '89 Toyota Camry out here, and we had the head off, and we did a whole bunch of work on this, that, and the other. We put it all back together, and when we cranked it up, there was a whole bunch of moisture coming out of the exhaust pipe, and actually puddling up on the ground behind the exhaust. And so I was scratching my head about that, and it was smelling really nice. This stuff that was on the, and what we figured out was that somebody had taken the windshield washer hose and hooked it to a vacuum port. And it was sucking windshield washer fluid through the engine and going right out on the back. Cleaned that thing up real good on the inside. All right. Typical causes include a defective cylinder head gasket, a cracked cylinder head, or in severe cases, a cracked block. You don't hardly ever see a cracked block. I mean, you know, sometimes. Now, sometimes most of the stuff you typically see is going to be a head gasket issue. You know, I mean, there's heads that crack and all, but usually it's a head gasket. A clicking noise can be a loose spark plug, loose accessory mount, alternator, power steering, loose rocker arm, worn rocker arm pedestal, fuel pump, broken mechanical, fuel pump, return spring, worn camshaft, exhaust leak, ping, clack would be your worn piston pin, broken piston, excessive valve clearance. What does it mean when you float a valve? It doesn't have time to close because you're screaming. You got the engine running so fast that the valve doesn't have time to close, and the piston can hit that valve too if you're floating. And Donnie had one that he got in over there that was one of these Chevys, and it had actually punched the rocker arms through the, punched the push rods through the rocker arms on several cylinders, and on some of them it had busted off the, the stud where it had broke those off flush because somebody was just driving that thing so hard and it was floating valves in and then when it hits like that, it's just really violent. It's bad. A knock's going to be your rod bearings, main bearings, thrust bearings, loose torque converter, cracked flex plate. Now the cracked flex plate will smack you around if you don't know what you're looking for. This one guy the guy that owns that red car you worked on this morning, he had one of these Dodge Cummins diesels that had 580,000 miles on it. And he started getting some engine noise out of it. And so he got another engine and he was putting the other engine in it, and when he had the engine out of the truck and swinging, he noticed that the flywheel was cracked.
I think that's the same car that's the problem. It's got a knot to
Yeah.
that area where the torque is at.
Yeah, well anyway, the point is, if you listen to an engine knock and you find that it's way up here in the bell housing area, then you're pretty doggone likely to have a problem with that. I like to put my stethoscope and listen to everything I can for transmitted, knock through the block or head or whatever. And then I take the end off the stethoscope and use it for a listening pipe. Because I have seen a situation where you could touch the engine oil pan, wouldn't hear the noise with the stethoscope, but when you screwed the end off the stethoscope and held it up there, it would be really loud. But it was not transmitting through the pan, but it was basically, you could hear it. And it was that balance shaft that you guys took apart last semester, that's what it was changed for. Was that thing? It's a $400-something shaft, but anyway. Rattle, manifold heat control valve. What is that? What's a manifold heat control valve? What we also called it was a heat riser. And on one side of some of these older engines on a V8, you would basically see this valve that would close when the engine was cold and force the exhaust that was trying to go out that side to go across through the intake manifold and go out the other side, because there's a passage where they get EGR on some of the later ones that goes through the top, and that warms up that area around where the throttle body of the carburetor is, so that when the atomized gas, when it's going through there, won't condense and stick to the side of the intake right there, because you're wanting that gas to stay atomized. And so after that heat riser had a bimetal spring on it, typically some of them were operated with a vacuum line and a diaphragm, that heat riser would open that thing up. And one time somebody brought an 84 F-150 to me that only had a few thousand miles on it and had been parked in a barn. And they said whenever we crank it up and let it run for a while, the carburetor gets so hot that gas starts boiling in it. And I said, well, I expect your heat riser is probably stuck closed because it sat there so long. So I broke that loose and got it where it would work, and all that went away. Sometimes you'll have a crazy thing that you can just think your way through. This is, well, see, you gotta look at the situation. It's a truck with not many miles on it. It's got a carburetor, it's an 84 model. It's been sitting in a barn for a long time because the old man that bought it apparently died and it just sat there. But it still had apparently good enough gas in it where it run. But whenever they cranked it up, they had boiling gas. What else it can be? Now, Chrysler vehicles used to have a carburetor called a thermoquad on them, and the body of the carburetor was plastic, and it kept the gasoline 20 degrees cooler in there and all that. But anyway, clatter would be rod bearings, pistons, and loose timing chain. When you hear what you also want to think about when you're hearing it is this thing cyclic? Is it wop, 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 wop? Is it making does it have a frequency that matches the firing of one cylinder? Or is it a rumble and a rattle sort of a thing like main bearings would make? Or is it a clack clack instead of a knock knock that may be a lifter issue? You know, that Dodge that we looked at that was skipping and cutting up and all that kind of thing. And we basically ran the run-in compression test and didn't really find anything that raised a red flag. But when we pulled the valve cover off, some of the bolts that held the cam caps had popped. You know, and it was difficult to, the only thing that led us there was the noise. You pull that off, you know. You can also take a dial indicator if you think the camshaft is around lock. We were talking about the best way to do it is to take the rocker arm completely off, set a dial indicator on top of the push rod, turn the engine through and see how much that dial indicator moves, and then you'll know if you've got the proper cam lift. You know, it's what we were talking about when I got there. And I don't know where he is now, but you know. All right, so a whining noise, generator, alternator, drive belt, power steering. Something else that can make a whining noise is a timing belt is too tight. Put a timing belt on, you get it too tight, you're going to hear it going, I've actually got a YouTube video where somebody put one on a 2.4 liter Chrysler Sebring out here, and it was making whining noises. And I knew instantly what it was. As soon as I heard it, I said, that timing belt's too tight. So he had to pull it back out, and he loosened the timing belt a little bit. A timing belt's got cogs on it. It's not like a serpentine belt, and you can tighten it too tight. And it will. Now, some timing belts have got round teeth, and some have square teeth, or, you know, squared teeth. And they have slightly different properties where this noise is concerned, so be aware of that too. Got a clump noise, check engine mount. If you see that, if you go to take off and you see the engine trying to pick up out of its cradle or doing this and all that, pretty good chance, you know, that you got an engine mount that's broken. Drive axle shaft U-joint or CV joint. The inside CV joint will make them do crazy vibrational kind of things that you'd swear was a bent wheel or something. Vacuums measured in inches of mercury. Normal engine's going to be 18 to 22. Normal cranking vacuum is going to be right about 5 inches. So cranking vacuum is important. If you're trying to check for a no start, you hook your vacuum gauge up with the throttle closed, spin it over. You ought to see it pull about 5 inches of vacuum. Weak valve springs, you're going to see the needle floating around. A sticking or burn valve. It'll float usually if you got weak valve springs, and it'll bounce real steady if you got sticking or burnt valve. Now a sticking valve can stick one time and not the next. A retarded valve timing is going to be low vacuum, and normal high RPM vacuum is going to be way up here. What could cause my vacuum to be higher than it's supposed to be? Very good. That's right. What else will that do? What else can that cause? Well, I mean, it can cause other symptoms. Advanced valve train timing, if it's a tooth or two off on valve train and it's advanced, what else can that cause? What about blue smoke? Why? Because it's pulling oil. You know, if you've got pressure in there like that, low pressure, and it also, when you're pulling that oil up in there, what does that do? It causes the compression to be high. When I first came here, there was a guy that came and taught a class that's for CarQuest Auto Parts, well, not CarQuest, but for Carport Auto Parts. He taught a class, and he says, and this was when I first came here. I hadn't been here 2 months. And when I first came here, I had 1 car that ran and 3 that didn't. And there was a little Honda car. I had a '87 Honda, and it ran. And he says, "You got a car that runs?" And he had a little vacuum waveform analyzer from Snap-on with him. I said, "Yeah, I got a car that runs." So I pulled that little Honda in here, and he'd never seen this Honda before. And he hooked up his vacuum waveform analyzer to it, and he looked at it, and he says, "Let's check the compression on this car." And he was pointing out, I've actually got a picture of the screen. And So he checked the compression, and the compression on that little 87 Honda car was like 230 pounds or 250 pounds or something. It was really high, you know. One of them was high compression. And he says, from what I see here and what I see there, this car is 1/2 out of town. And I thought, I don't know about that, you know. What's this guy talking about? So anyway, he went ahead and finished his class and left and all that. And I had some of my people pull it down, and I says, I want to line the timing marks up, and it was 1/2 out of town. Just like he said. He looked at a vacuum waveform analyzer, he looked at a compression test, figured it out. And I thought that was pretty darn cool. I mean, there's some people that can do that, you know. Mac Vandenbrink can look at a scope pattern and tell you if you got a rounded off lobe on the camshaft, you know, which is pretty sharp. Gauge reading with a needle fluctuating 3 to 9 inches below the normal is a vacuum leak in the intake system sometimes. I mean, that's, yeah, it's going to have to be a big leak if it's going to have low vacuum like that. I have seen vacuum leaks that people, oh yeah, this is low vacuum, and this is a vacuum leak. But I mean, and they would have late valve timing because of some reason or another and swear it had, because it had low vacuum. Low vacuum is, it's possible for it to be a vacuum leak, but it better be a big one, because that won't usually do that. I had a one time, and I got a picture of that over here, on one of these plastic manifolds, on one of these Rangers. And when you crank it, it would try to run away and then it would die. Crank it, try to run away, and it would die. And what had happened on that was, one of these little hoses that goes to the DPFE sensor had popped off and was blowing red hot exhaust, or really hot exhaust on that plastic manifold. And underneath that manifold, it had burned a hole in that manifold that big around. And that thing wouldn't even crank and run because of that big, you know, air leak, and it had mass air leak. All right. A leaking head gasket can cause the needle to vibrate as it moves through the range, you know. So basically, these are sort of nebulous things that you won't always be able to look at the needle and say, yes, that's a head gasket. I mean, you know, basically you get indications. You got to gather various different data from various different places before you'll know for sure, before you found a smoking gun. Now, if I look at a vacuum gauge on an engine that's skipping, and I see the needle going boop, 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 bouncing with the skip, that's going to be a valve problem just about every time. I don't know of any time anything else it would be, and I've seen that on more than one occasion. It doesn't matter if it's an intake valve or if it's an exhaust valve that's burned or stuck open all the time or whatever. That is gonna, it can cause the needle to bounce. Now, how can an exhaust valve cause the needle to bounce? You can understand how the intake valve would, right? Well, why would an exhaust valve cause the needle to bounce?
Maybe it's not opening up enough.
If the exhaust valve is not sealing and that piston's going down, it's going to be pulling air in from the exhaust, isn't it? So you can, either one of the valves being burned can cause it to have a bouncing needle. All right, an oscillating needle 1 or 2 inches below normal could indicate an incorrect air fuel mixture. That's your carburetor adjustment. We used to use a vacuum gauge when we were adjusting carburetors, and we set that thing so that the needle was as high as it would be and nice and steady. You know, you can do it by ear. My dad used to adjust them dual carburetors on some of those Volkswagen Type 3s, 67 and back. The 68s had fuel injection on them. And he would listen to it with a big piece of paper hose. And then he would fill up it with his fingers, and he'd turn them things, and he'd listen to it again. I don't know what he was listening for. He never did teach me anything like that, but he could fix them doggone things. And then fuel injection came out in 68. He was working on fuel injected cars years and years and years before any American car had one on it. But you could buy anything you needed for those old Volkswagen fuel injector engine controllers and all from Radio Shack. You could just about buy most of what you needed there to fix one of them. You had a couple of sets of points underneath the breaker plate in the distributor that gave it the injector, you know, trigger thing. All right, but anyway. A rapidly vibrating needle at idle that becomes steady as engine speed increases indicates worn valve guide. You know, if the valves are moving around down in there and they don't always close the right way, not going to spend a ton. If the needle drops 1 or 2 inches from the normal reading, the valve is burned. That's this bouncing thing I was talking about. All right. Weak valve springs will produce a normal reading in idle, but as engine speed increases, the needle will fluctuate rapidly between 12 and 24 inches of mercury. All right, so you got some weak valve spring there. Like I say, a lot of this stuff is not smoking gun stuff. You're going to have to follow up and gather more data before you can make a steady diagnosis. If you got a steady needle reading that drops 2 or 3 inches when the engine speeds increase slightly above idle, that's your ignition timing retarded. You know, low vacuum can be valve timing or ignition timing typically. Steady needle reading that rises 2 or 3 inches when the engine speeds increase, the ignition timing is retarded. A needle that drops near 0 when it's accelerated rapidly and then rises slightly to a reading below normal is exhaust restriction. If you're giving it the gas, now I will tell you this, if you've got a loaded engine, I mean an exhaust restriction is basically kind of like a load on the engine. You got me? So if you put your engine in, you put your brake foot on the brake and put it in drive, and you hold the foot on the gas, you can make that vacuum go down and stay down. It simulates exhaust restriction. Exhaust restrictions are kind of, well, they can be really bumfuddling if you don't know what's going on there. But if you understand what you're looking for and you can kind of feel of it, like for example, that catalytic converter right there above his head came off of a Trailblazer. It just didn't quite feel like it had the power it used to have. And we took the oxygen sensor out from in front of the catalyst and we were reading like 5 pounds of pressure. You're not supposed to read any pressure in front of the catalyst. We read 5 pounds of pressure and that was enough of a smoking gun that we took the catalyst off, cut it out of there, and you could see that it was clogged up. You can look at it and tell us what it was. It wasn't completely clogged, but it was clogged enough where he was having issues. Right? And he said he knew something wasn't right. But you could do all of your scan tool testing and all of this, and you really didn't see much of anything that led you in that direction. We actually did a physical pressure test. We also saw that on and the shooting the exhaust in front of and behind the catalytic converter with a temperature gun, that's okay, but it's not 100%. We had a Monte Carlo in here. It was a 3.4 in it, I think. And whenever we'd shoot in front of the catalytic converter, you're actually supposed to be cooler in front of the converter than behind the converter, right? But if you shoot it in front of the converter with your temperature gun and you see 500 degrees and behind it is 200 degrees, yeah, that's a smoking gun. But we shot it in front of the catalyst and saw about 280 degrees, and behind it we saw 480 degrees. That didn't mean the catalyst wasn't stopped up. So some of your tests are like that. Some of your tests you can take it to the bank whenever it fails the test, but just because it passes, it doesn't mean you forget about the catalyst and move on. Best to check the pressure. And on that one, when we checked the pressure, and I've got a picture of that somewhere, we drilled a little 1/8 hole right in front of the catalyst and held a vacuum gauge just right up against that hole, and that pegged the gauge. Just slammed it all the way around to 30 pounds. And I think we got Jesse James Duke holding that thing with his eyes like this because it was so hot under there, and he's trying to hold it. He didn't get burned, but he had big eyes. All right, compression loss, intake, exhaust piston or piston ring, cylinder head gasket. Everybody knows how to do a compression test. Block open the throttle and the choke if it's equipped, and that lets the maximum amount of air in there. Most mechanics won't hold the throttle open when they're doing a compression test. They'll just do a compression test, right? And you can tell like that typically. Disable the ignition system. You don't want fuel squirting in there while you're doing your compression test. You don't want sparks popping, okay? So do whatever you got to do to make that stop. If you have to pull your computer, your main relay to stop that or whatever, put your compression gauge, crank the engine, continue through 4. I like 6 compression strokes. Pump, 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 pump. That bounce up there. If your Schrader valve is bad in your compression gauge, it won't hold the pressure. You whoa, 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 whoa. And it pumps up and you walk out here and it's bleeding down. That's nothing wrong with the engine. That's your compression gauge needs a new Schrader valve in the bottom of it, that one tight. So, reading on the compressor gauge at the first puff, that should be at least 1/2 of the final reading. Now that's an interesting little spec there. If the final highest reading is 150, the reading after the first puff should be higher than 75. The first puff reading indicates a possible weak or broken piston readings like that if it's lower. All right, record the highest readings, compare the results. What's this? See that? High reading, 150, subtract 20%, 120. It should not be any lower than that if the highest one is there. So the lowest shouldn't be any less than 30% of the highest. You want a good balance for the most part, what you're shooting for. If the reading indicates low compression, 3 squirts of oil to the cylinder helps seal around the piston rings. Retest it if the compression comes up. you pointed the ring. You're gonna see it come up a little sometimes, but it won't come up a whole lot if you got valves. Usually not very much. Don't put too much oil in there because fluid won't compress. One of these shops over here took one of our Crown Victorias, they're gonna put an intake on it, and when they pulled it in there, and they drove it into the shop, they pulled the intake off, they put another intake back on it, and then they called the guy and told him it needed an engine. Think about this, you drive it into the shop, you change the intake, you put it back on, it needs an engine. Well, what's wrong with the engine? Well, it's locked up. Well, wait a minute, you drove it into the shop, and now it's locked up? See what I'm saying? Something's rotten in Denmark about that. And what had happened was, when we got it over here, we tore it down and they had actually, some liquid of some kind had got in on top of cylinder number 8. And when that thing came up and all that liquid was in there, it bent the rod. And then whenever the piston went back down, it hit the crank counterweight. And that's why it was locked up. It wasn't like that when they pulled it into the shop, right? All right. Be careful about hydraulic locking something. You know, if you actually feel like there's a bunch of fluid that has gone in a cylinder, pull your plugs out and bar the cylinder over until you push the fluid out. Do something to get it out of there. Don't feel like it'd be a height. You know what I'm saying? We don't want to go there. All right. You do the cylinder leakage test. You're going to shoot air into the cylinders one at a time, rotating it by fire in order to test each cylinder at TDC on the compression stroke. Less than 10% is good. Less than 20% is acceptable. Like Zane did this the other day on that truck that he was looking at. More than 30% is a problem. We had nearly 100% leakage on that. Listen to where the oil, the air is coming from. If it's coming out the exhaust, intake, crankcase, whatever, you can get an idea of where the compression is going. Cylinder power balance test is when you kill the cylinders one at a time. The really cool ones are the ones you can plug a scan tool in and kill the cylinders while they're running and listen. But you know, your misfire detection on using your cam and crank sensor is pretty good. You can go into mode 6 and see how many misfires there were if you know how to interpret that data there too. If the engine speed doesn't drop as much for one cylinder as the other ones, which pull in the wires or injectors, if one of them doesn't make any difference, you'll know that's the one that's skipping. What if I'm working on one, like let's say I got my old 350 Chevy out there, and I'm looking for a skip, and I pull the plug wires in it. Well, I pull one and it starts running better. I check my firing order, it's like it ought to be, but I pull the plug wire off and the engine picks up speed. There's one guy that's working with me down there. I said, what do you do if you pull the spark plug wire and it picks up speed and it starts running better? He goes, I don't know. Pull 2 or 3 more off, maybe it'll run really good. But if it's got a carbon track in the distributor, sometimes when you pull one of the plug wires, it'll run better. Because that cylinder is actually fighting it, you see. All right. Operate the engine to normal operate, oil pressure test. Basically, you're finding out what is the health of the engine. We're talking about the bottom, the top end, and we're talking about the bottom end. And the oil pressure test, look at it, record the pressure at idling 2,500, 10 psi per 1,000 RPM is a rule of thumb. The red oil pressure warning lamp usually lights when it's less than 4 to 7, depending on the vehicle. Clean it up around an oil leak like we were doing the other day. We wash everything down. You can spray it with Dr. Scholl's foot powder. Paint it white and then see where that oil starts coming. Good way to do it. You can also find wind noise in the door. If you paint the door gasket with Dr. Scholl's powder, close the door real gently and open it back up, the place where it's not touching will be where your wind noise is a lot of times. Okay, avoid letting the water come into direct contact with the air inlet, so on and so forth. Fluorescent dye, we've used that too, everybody's done that. 15 cubic centimeters of dye per 5 quarts of engine oil. Let it run about 10 minutes. Sometimes to find an oil leak, you'll have to drive the car down the road. Is it a splash leak? Is it a pressure leak? If it's a pressure leak, you're going to have the pressure up for a little bit sometimes before it'll ooze out of there. Pressure is going to be higher when you're driving. If it's a splash leak, you can actually stop up your PCV and your PCV closure and put a hose on the dipstick tube and put about 10 pounds of air pressure on the crankcase and go with soap bubbles looking for where the air is coming out. You'll find a splash leak that way, which is pretty good. We used to do that in Ford plant. And that's the end of the slideshow. What a pleasant surprise. It just happens to be right here at lunchtime. Okay, what do you know? What are you taking with you that you didn't come in here with?
You should always stop
Collect
it.
all the data, because just looking at one gauge, it can tell you a whole bunch of different things.
Exactly. I mean, if you're just looking at one test, now there's some tests, if it fails that you're done, but if it passes some tests, you may have to go in and gather more data before you can clear that component. That's a good thing to take with you.